You have two options when calling another program synchronously. Insert. The process flow of the calling program pauses while the called program executes and resumes when the called program is complete. New Start. The calling program terminates and the called program starts. Complete programs can only run in a sequence within a single user session. SAP refers to this processing scheme as sequential calls. To run activities in parallel, you must use function modules.
To start an executable or Type 1 program, use the Submit statement. If you use the VIA Selection Screen edition, the system displays the standard selection screen. If you use the AND Return edition, the system resumes processing with the first statement of the calling program after the Submit statement once the execution of the called program finishes. Note, for more information, see the ABAP keyword documentation for the Submit statement.
When you call ABAP programs that have a standard selection screen, you can pass data for the input fields in the call. Data for input fields can be passed in the following ways: by specifying a variant for the selection screen when you call the program, by specifying specific values for the input fields when you call the program.
The with addition in the Submit statement allows you to assign values to the fields on a standard selection screen. The relational operators such as EQ, NE, and so on, and the inclusion operators I and E are similar in meaning to select options. If you want to set several selections for a selection option, you can use the range type instead of individual with additions. Using the range type creates a selection table that you can fill as though it were a selection option. You then pass the table to the executable program. The pattern automatically supplies the names of the parameters and selection options that are available on the standard selection screen.
If you use the leave to transaction T_code statement, the system terminates the current program and starts the transaction with transaction code T_code. This statement is the equivalent of entering /NT_code in the command field. With the call transaction T_code statement, you can pause the execution of the calling program until the called program finishes its execution. You can use the leave program statement to force the termination of a program. For cases in which this statement executes in a program called by call transaction T_code or submit PROG_name and return, you continue with the next statement after this call. In all other cases, the system returns to the application menu from which the user started the program. If you use the and skip first screen edition, the system does not display the contents of the first screen in the transaction. Caution: the system does process the flow logic.
When you call a transaction using the call transaction T_code using BI_ITAB statement, you can run transaction T_code using the values from internal table BI_ITAB in the screen fields. This internal table must have the global structure type BDC data, and you should fill it accordingly. You can use the return code SYSUBRC to verify that the system executes the transaction successfully. This technique of passing data using an internal table is useful in the following cases: processing in dialog, but not filling the input fields using get parameters; processing the transaction in the background, in which case where you must pass the function codes in the table as well.
The technique of passing data using internal table is also one of the possible ways of transferring data from non-SAP systems. When doing so, you must fill the internal table with a global structure BDC data. The figure shows an example of the transaction BC402_CALD_CTA_U. When the user creates a new customer entry, the program calls transaction BC402_CALD_CRE_CUST. This transaction does not implement an import from ABAP memory, and the transaction input fields are not set as get parameters. After the call transaction statement, the system passes the customer data using an internal table and processes them in background. If the operation is successful, you can enter new customer record in the waiting list. The figure shows the internal table in that you fill in BDC data format. At runtime, current_name stands for the customer name from the input field, and current_city stands for the city. Address the command field using BDC_OK code, which captures the function code that the user triggers by choosing a function key, button, or menu option during the dialog flow. The user can also enter a code directly in the command field.
Development objects are stored in the repository in the form in which they are developed. These are the only versions of the development objects that can be displayed in the workbench. To run a program in the ABAP runtime environment, you must first generate the program using the ABAP compiler. When you generate a development object, the system generates a runtime object or load. The load consists largely of bytecode statements that are linked to C functions. To avoid generating programs every time they run, save program loads in the database and buffer them on the application server.
When you change a development object and save it, the system creates an active version and an inactive version. Saving an inactive version has no effect on the program load. Accordingly, the syntax of the inactive version does not necessarily have to be correct. You can also save an interim, non-executable version of the development object inactively. However, the active version remains available as an executable version. You can toggle the view between the active and inactive versions, but you can only edit the inactive version. The system performs a syntax check on the version in development, that is, the inactive version, but not on the generated version. When running source code for executable programs from the ABAP editor, the system refers back to the inactive version. In this case, the system creates a temporary generated version that is not buffered or stored in the database. In all other cases, the system always accesses the active version when you generate the program.
All inactive objects that the system assigns to your user ID are listed in your work list. The following steps occur when you activate an object. The object is saved. That is, a new inactive version is created. This is subject to a syntax check. The system overrides the current active version. The previously inactive version is now the active version, which means there is no longer an inactive version. The system creates a new runtime version and updates the load. When the runtime system generates a new runtime object, that is the load of a program, or loads it from the database, it places the program in the working memory of the application server. In the process, the runtime system treats the modifiable parts of the program differently than the non-modifiable parts. The system stores the non-modifiable parts of the program in the PXA and buffers to the maximum. This memory area is shared by all users on the application server and exists only once on each server. After the system executes a program, the program's bytecode remains buffered in the PXA to the maximum extent. Buffering prevents the system from loading the code from the database again during the next execution. The modifiable parts of the program are created in the memory during every execution, in a memory space called the role area, when the program executes several times concurrently by the same user or different users. Each execution has its own role area. This ensures that the system executes the programs independently of one another.
The figure shows the way in which main memory is organized from the program's perspective is represented in the figure.
When a program calls external modularization units, the system loads the corresponding programs into the same internal session. The programs within an internal session form program groups. When the system opens an internal session with a program call, the system always creates the main program group. There can be one or more additional program groups. Each program group contains one main program and other programs as well. The program data objects are only visible within its program group, which means programs in different program groups do not share any data objects. All programs and objects of an internal session can use instances of classes. An object continues to exist as long as there are users, that is, references for it.
The figure illustrates how a stack of internal sessions inside an external session changes with various program calls. When inserting a program, the starting point for the first case is the execution of the submit and return or call transaction statements within a program. When you insert a program, the system creates a new internal session which contains the new program context. The system places the new session in the stack. The program context of the calling program remains in the stack.
When the called program is completed, the system deletes the called program's internal session, that is, the top one in the stack. The system then begins processing the next highest internal session in the stack.
The system makes a distinction between calling an executable program and calling a transaction with regard to memory areas. The starting point for the second case is the execution of a submit statement within a program.
When you start an executable program with the submit statement, the following actions occur. The system ends the calling program. The system destroys the internal session of the program that you are terminating, that is, the top program in the stack. The system creates a new internal session, which contains the program context of the called program. The system then places the new session in the stack and retains any previously created program contexts. The topmost internal session in the stack is thereby replaced. The starting point for the third case is the execution of a leave to transaction statement within a program. When you start a program using its transaction code, the system destroys all internal sessions in the stack. The system then creates a new internal session which contains the program context of the called program. The system initializes the complete stack of internal sessions, which also means it initializes the ABAP memory after the call.
When you open an internal session, the system always creates the main program group. You can also create any number of additional program groups in the same internal session. Each program group has only one main program. An additional program is created in the following cases. When the program calls a function module from a function group that has not yet been loaded. When the program calls a method of a global class that has not yet been loaded.
When two programs running in different internal sessions call up function modules from the same function group, the system loads the function group into each of the internal sessions separately. The system creates the global data of the function group separately in each internal session. Therefore, there is no possibility or risk of the two main programs exchanging data through the function group.
When programs that run in different internal sessions use the same global class, the global class is created separately in each internal session. The static attributes of the class can have different values in different internal sessions. When two programs run in the same internal session, for example, an executable program and the AB function group it addresses, and both programs address the same XY function group, then the system loads the function group XY in the internal session once. Therefore, the main program and function group AB can exchange data using function group XY. The same applies for global classes. In practice, this situation can result in frequent errors because the main program and function group AB or class CL_A affect each other inadvertently. The main program may buffer data in function group XY, for example, but function group AB or class CL_A can unintentionally overwrite the data or initialize it. This can result in program termination and even data inconsistency. The causes of such errors are difficult to find, particularly when the program does not use the function group AB or class CL_A directly and uses other function groups or classes instead. Hint: when the shared program is a global class, that is, class CL_B in the figure, there is only a risk of unintended interaction with regard to the static attributes. The two programs used see only the same instances and therefore the instance attribute values of a class when they specifically exchange references to these instances. An elegant way of avoiding unintended interaction for global classes is to use instance attributes instead of static attributes. Also make sure that every user of the class generates a separate instance. When the user calls a subroutine externally, the system does not generate any new program group in the internal session. Instead, it loads the main program of this subroutine into the calling program's existing program group. Hint: subroutines of a function group are an exception. When a subroutine of a function group is called externally, the system loads the corresponding function group into an additional program group.
Some techniques for passing data are as follows. Interface of the called program, ABAP memory, SAP memory, database tables, local files on the presentation server.
When you need to transfer data between two different programs but cannot specify the data, as an addition in the program call, you can use the SAP memory and the ABAP memory to transfer data between programs. Consider the following while using SAP memory and ABAP memory to transfer data between programs. The SAP memory is a user-specific memory area for storing field values. It is therefore not useful for passing data between internal sessions. The system retains values in the SAP memory for the duration of the user's terminal session. You can also use the SAP memory between sessions in the same terminal session. All external sessions of a user session can access the SAP memory. You can use the contents of the SAP memory as default values for screen fields. The ABAP memory is also user-specific. There is a local ABAP memory for each external session. You can use a local ABAP memory to exchange any ABAP data objects such as fields, structures, internal tables, and complex objects between the internal sessions in any one external session. When the user exits an external session in the command field, the system automatically initializes or releases the corresponding ABAP memory.
The export to memory statement copies any number of ABAP data objects with their current values, that is, data cluster, to the ABAP memory. The ID addition, which can be a maximum of 60 characters long, enables you to identify different clusters. When you use a new export to memory statement for an existing data cluster, the new statement overwrites the old one. The import from memory statement allows you to copy data from the ABAP memory to the corresponding fields of your ABAP program. You can also restrict the selection to a part of the data cluster in the import statement. The variables into which you want to read data from the cluster in ABAP memory must have the same types in both the exporting and the importing programs. You can define memory areas called parameters in the SAP memory in different ways, such as the following. You can create input or output fields with reference to ABAP dictionary. These fields take the parameter names of the data elements to which they refer. Alternatively, you can enter a name in the attributes of the input or output fields. Then, you can also choose whether you want to transfer the entries from the field to the parameter or set, or fill out the input field with the value from the parameter or get. To find out about the names of the parameters assigned to input fields, display the field help using the F1 key and choose the technical info push button. You can also fill out the memory areas directly using the set parameter ID, PAR_ID field variable statement, and read from them using the get parameter ID, PAR_ID field variable statement. You can define parameters in Object Navigator and let the user enter the values.
Memory management treats deep data objects and flat data objects differently.
Flat data objects are elementary data types with fixed lengths and structures that only have flat components. The content of flat data objects represents actual working data. The system reserves memory for flat data objects as soon as it loads the program into the internal session. The system does not release the memory reserved for flat objects until it deletes the internal session.
When the system loads a program, it creates only a reference for the statically declared deep data objects at first, such as strings and internal tables. The static memory requirement for this reference is 8 bytes. When you use the deep data object, additional working memory is requested at program runtime. For dynamic data objects such as strings and internal tables, this memory is for the administration information, that is, header, and the data object itself. The memory requirement for a header depends on the hardware platform, but is 100 bytes. When the requested or allocated memory is not sufficient for later access, additional memory can be reserved. When you initialize a string with clear or free, the system deletes the data, but the reference variables and the header are retained and reused during the next memory request. Accordingly, when a string has been used and then deleted, its memory requirement consists of the reference and the requirement of the header.
Memory management for internal tables is similar to management for strings. Memory management for internal tables is different from the management of strings as follows. The headers of internal tables require more memory than other headers because internal table header data can be distributed among several blocks. This means that internal table header can manage references to these blocks. The clear, refresh, and free statements have different effects. Clear and refresh only delete the data, while free can also delete the table header when it takes up too much memory. The amount of memory that is allocated during initial access can be changed when you define the internal table. Optional addition, initial size.
To minimize runtime and conserve memory, assigned values are shared between strings and between internal tables. Sharing means the system initially does not copy the actual data values during an assignment. Instead, it copies only the necessary management entries. The target object, therefore, refers to the same data as the source object. When strings are involved, the second internal reference is filled to point to the existing string header. The system cancels sharing when you access either the source or the target in the change mode. This approach is called copy-on-write semantics. In this case, the system actually copies data values and changes the references and header accordingly. With internal tables, only the actual data is shared. The system assigns each table a separate table header which refers to the existing table body. Tables whose line types contain other table types are not shared. Hint, sharing is also used to pass values to procedures. Therefore, there is no major difference between using call by value and call by reference with regard to runtime requirements for passing strings and internal tables to forms. A runtime-intensive copy operation takes place if you use call by value and then access the formal parameters in change mode within the procedure. In contrast, when you use call by reference, the actual and formal parameters continue to use the same memory.
As of SAP NetWeaver 7.0 EHP2, you can use boxed components to reduce the memory consumption of static data objects.
The figure illustrates an example of a nested structure with a boxed static substructure. The contents of the boxed subcomponent SUB are not stored inside the structure GS_boxed directly. Instead, the subcomponent is internally represented by a reference. As long as the subcomponent is still initial, this reference points to an appropriately typed initial structure stored centrally in the PXA. This is called initial value sharing for boxed components. The system revokes the initial value sharing if, for example, a write access to the substructure takes place, after which the substructure is no longer initial. As shown in the figure, the system creates the substructure dynamically within the internal session of the program and changes the reference so that it points to the new substructure. Hint, once you revoke the initial value sharing, it is retained. The clear or free statement only initializes the components of the substructure but does not release the memory allocated for the substructure.
The figure illustrates an example for an instance attribute of a class defined as a boxed component. If the boxed attribute remains initial in many instances of the class, all instances share the same initial value. This can significantly reduce the memory consumption of the program.
You can reduce the overall size of an internal table if you use a structure type having a boxed component as line type. This is illustrated in the figure.
Boxed components should fulfill requirements such as follows.